I think so. I think it's really, I'll take a specific example from neural interfacing. It's a very common problem that when you work with the brain, you're in this super high dimensional space and you don't necessarily know how to think in 400 dimensions, for example. But one of the real key pushes in that is exactly visualization techniques, so we can understand quickly what is the important aspects of that data, what is the feature that really describes it. So instead of thinking of the problem as I said earlier with the multitasking, we have to be able to do 10 things at once, instead it's important to process this massive stream of data so I can get the relevant features out of it.
I think that the granularity in which we are able to derive information of the brain is still very small, but with the use of massive computational power and also the development of nanotechnology, it's possible to collect more and more data, and with this amount of data it's then on the other hand possible to simulate and to learn more about the brain in order to develop devices which can assist them.
I think once we open these new pathways to send information into the brain, what we send in there and how the brain can cope with it is up for research. So it could be something as simple as the reading from a thermometer and try to transmit information about temperature, or it could be information about internet network activity.
I believe that this is what we naturally do. I mean, this is what the brain does. The brain deals with a massive amount of data and through consciousness selects what it's interesting in that moment. So what we are trying to do is something similar to this. We are trying to extract some aspects of a massive amount of data, which is the brain data, brain signals. We're trying to extract some relevant information that is specific to the task the person needs to accomplish. And for sure, I believe that we will be able to deal with this data, either from a technological point of view and from a practical point of view, depending on what is the final target of the application we're developing.
So you think that we can learn to interact with and understand massive amounts of data?
Certainly, because if we think of the confluence between the human brain and the intelligent devices that our computers are already capable to implement, it comes very naturally to put them together and say, bringing them together, we can do much more than individuals. So imagine the following situation. A person, disabled or not, that is moving around in a crowded environment, and all of a sudden this person is capable to recognize people he or she wants to talk to. But because of the constraints of the environment, it is too difficult to reach that person. So what if at this point, once, say, our brain is telling through this brain-machine interface, there is a relevant information out there, then you can combine many more information that is giving you the context, where the person was looking, the position, etc., with computer vision technology to say, this is the person that triggered the attention of the subject. Now let's try to contact that person. This is one very simple example, but for me it illustrates quite well.
I think we do that all the time. Learning how to, in everyday life, every time we do anything, we lift a glass, we drink something, or we learn a new tune on the piano, we are actually managing a huge amount of data. But we are not paying the same attention to all of that, because we are working on in a distributed fashion. So we have to simplify the situation, in my understanding, we have a sort of a cognitive level where we work in terms of symbols, and we have a signal level where we work in terms of stimuli, like nervous stimuli. We have to create a hierarchy of uncertainty, of different levels of uncertainty. So whatever is a signal level near the sensor is more certain, but more difficult to manage. When we move on to more cognitive levels where we have symbols, let's say, in that case we have more uncertainty, but we have a better ability to master this uncertainty. So I believe that it all depends on how what meaning we give to processing huge amounts of data or understanding huge amounts of data. I think that in order to do that, I think we can, because we do it all the time, and we can fairly quickly if we give the right level of importance to each one of these levels, and we learn how to manage uncertainty. If we are talking about learning how to process everything with absolute certainty, thinking in terms of the traditional computer, I don't believe we can.
Well, I think now we are faced with the problem that we have. We are really, we don't have a problem of information. There is a lot of information available. The problem is how to handle this information. And I think that studying how the human brain works, how we interact with other humans, we can start thinking about how to share and how to handle this massive amount of information that is available. But it's really important on one side to develop new technologies, and on the other side to understand better the human brain. And the only way to do that, or one possible way to do that, is actually to study robots and humans at the same time, and how they can exchange this information.
It's difficult. It's certainly a difficult problem, and there's clearly a sense that we're being overwhelmed by large volumes of data currently, but it's clearly a problem of presentation, because and I think with research into visualization techniques and kind of, let's call it compression techniques, or alternative representative structures, it is possible for us to I suppose, to bring vast volumes of data into cognitively tractable and manageable entities and artifacts. It's not something I know a lot about, but I do know. I'd have great confidence and faith in modern engineering and science to deal with that problem. Difficult though, yeah.